An overtone is any frequency greater than the fundamental frequency of a sound. Using the model of Fourier analysis, the fundamental and the overtones together are called partials, harmonics, or more precisely, harmonic partials are partials whose frequencies are integer multiples of the fundamental. These overlapping terms are variously used when discussing the acoustic behavior of musical instruments. The model of Fourier analysis provides for the inclusion of inharmonic partials, which are partials whose frequencies are not whole number ratios of the fundamental. When a resonance system such as a blown pipe or plug string is excited, a number of overtones may be produced along with the fundamental tone. In simple cases, such as for most musical instruments, the frequencies of these tones are the same as the harmonics. Examples of exceptions include the circular drum, a timpani whose first overtone is about 1.6 times its fundamental resonance frequency, gongs and cymbals, and brass instruments. The human vocal tract is able to produce highly variable amplitudes of the overtones, called formants, which define different vowels. Explanation: most oscillators, from a guitar string to a flute, will naturally vibrate at a series of distinct frequencies known as normal modes. The lowest normal mode frequency is known as the fundamental frequency, while the higher frequencies are called overtones. Often, when an oscillator is excited by, for example, plucking a guitar string, it will oscillate at several of its modal frequencies at the same time. So when a note is played, this gives the sensation of hearing other frequencies above the lowest frequency. Timbre is the quality that gives the listener the ability to distinguish between the sound of different instruments. The timbre of an instrument is determined by which overtones it emphasizes. That is to say, the relative volumes of these overtones to each other determines the specific flavor or color of sound of that family of instruments. The intensity of each of these overtones is rarely constant for the duration of a note. Over time, different overtones may decay at different rates, causing the relative intensity of each overtone to rise or fall independent of the overall volume of the sound. A carefully trained ear can hear these changes even in a single note. This is why the timbre of a note may be perceived differently when played staccato or legato. A driven nonlinear oscillator, such as the vocal folds, a blown wind instrument, or a bowed violin string will oscillate in a periodic, non-sinusoidal manner. This generates the impression of sound at integer multiple frequencies of the fundamental known as harmonics, or more precisely, harmonic partials. For most string instruments and other long and thin instruments such as a bassoon, the first few overtones are quite close to integer multiples of the fundamental frequency, producing an approximation to a harmonic series. Thus, in music, overtones are often called harmonics. Depending upon how the string is plucked about, different overtones can be emphasized. However, some overtones in some instruments may not be of a close integer multiplication of the fundamental frequency, thus causing a small dissonance. High-quality instruments are usually built in such a manner that their individual notes do not create disharmonious overtones. In fact, the flared end of a brass instrument is not to make the instrument sound louder, but to correct for tube length and effects that would otherwise make the overtones significantly different from integer harmonics. This is illustrated by the following. Consider a guitar string. Its idealized first overtone would be exactly twice its fundamental if its length were shortened by 1/2, perhaps by lightly pressing a guitar string at the 12th fret. However, if a vibrating string is examined, it will be seen that the string does not vibrate flush to the bridge and nut, but it instead has a small, dead length of string at each end. This dead length actually varies from string to string, being more pronounced with thicker and/or stiffer strings. This means that halving the physical string length does not halve the actual string vibration length, and, hence, the overtones will not be exact multiples of a fundamental frequency. The effect is so pronounced that properly set up guitars will angle the bridge such that the thinner strings will progressively have a length up to few millimeters shorter than the thicker strings. Not doing so would result in inharmonious chords made up of two or more strings. Similar considerations apply to tube instruments. Musical usage term. An overtone is a partial that can be either a harmonic partial other than the fundamental, or an inharmonic partial. A harmonic frequency is an integer multiple of the fundamental frequency. An inharmonic frequency is a non-integer multiple of a fundamental frequency. An example of harmonic overtones. Some musical instruments produce overtones that are slightly sharper or flatter than true harmonics. The sharpness or flatness of their overtones is one of the elements that contributes to the unique sound. Due to phasing consistencies between the fundamental and the partial harmonic, this also has the effect of making the waveforms not perfectly periodic. Musical instruments that can create notes of any desired duration and definite pitch have harmonic partials. A tuning fork, provided it is sounded with a mallet that is reasonably soft, has a tone that consists very nearly of the fundamental. Alone, it has a sinusoidal waveform. Nevertheless, music consisting of pure sinusoids was found to be unsatisfactory in the early 20th century. Etymology. In Hermann von Helmholtz's classic On the Sensations of Tone, he used the German Overtone, which was actually a contraction of ober partial tone, or in English, upper partial tones. According to Alexander Ellis, the similarity of German ober to English over caused a Professor Tyndall to mistranslate Helmholtz's term, thus creating overtone. Ellis disparages the term overtone for its awkward implications, because overtone makes the upper partials seem like such a distinct phenomena. It leads to the mathematical problem described above where the first overtone is the second partial. Also, unlike discussion of partials, the word overtone has connotations that have led people to wonder about the presence of undertones. Overtones. In barbershop music. In barbershop music, the word overtone is often used in a related but particular manner. It refers to a psychoacoustic effect in which a listener hears an audible pitch that is higher than, and different from, the fundamentals of the four pitches being sung by the quartet. The barbershop singer's overtone is created by the interactions of the upper partial tones in each singer's note. Similar effects can be found in other a cappella polyphonic music such as the music of the Republic of Georgia and the Sardinian canto a tenor. String instruments can also produce multiphonic tones when strings are divided in two pieces. The most developed instrument for playing multiphonic tones is the sitar, in which there are sympathetic strings which help to bring out the overtones while one is playing. The most well-known technique on a guitar is playing flageolet tones. The ancient Chinese instrument the guqin contains a scale based on the knotted positions of overtones. Also, the Vietnamese thun bu functions on flageolet tones. Other multiphonic extended techniques used a prepared piano, prepared guitar and third bridge. Overtone singing. Overtone singing, also called harmonic singing, occurs when the singer amplifies voluntarily two overtones in the sequence available given the fundamental tone she is singing. Overtone singing is a traditional form of singing in many parts of the Himalayas and Altai. Tibetans, Mongols and Tuvans are known for their overtone singing. In these contexts it is often referred to as throat singing, though it should not be confused with Inuit throat singing, which is produced by different means. Jaw harp. A similar technique is used for playing the jaw harp. The performer amplifies the instrument's overtones by changing the shape, and therefore the resonance, of the vocal tract. Free reed aerophone. Likewise, when playing a harmonica or pitch pipe, one may alter the shape of the mouth to amplify specific overtones.